everyone, this is Kalpana here. So in this video we are going to see a problem from functions of complex variable. Problem: find d by dz of sine z. That is derivative of sine z with respect to z. Solution: we know that z equals to x plus iy. Okay. So sine z will be sine of x plus iy. Since sine a plus b equals to sine a cos b plus cos a sine b. Now we can apply this formula. So we'll get sine x cos iy plus cos a cos x into sine b sine iy. Okay. Since sine ix equals to I sine hx and cos ix equals to cos hx. Now replace cos iy by this and sine iy by this. Okay. So this becomes sine x into cos iy will become cos hy. Here is our variable plus cos x into I sine hy. Okay. So this equals to sine x cos hy plus I into cos x into sine hy. Therefore, sine z equals to sine x cos hy plus I into cos x sine hy. Okay. So we are having sine z. Now we'll use the sufficient condition of analytic, that is f dash of z equals to ux plus ivx. Okay. Now using sufficient condition of analytic, that is f dash of z equals to ux plus ivx. Okay. Ux is nothing but dou u by dou x plus I into vx is nothing but dou v by dou x. So this is equals to dou by dou x of, so this will be our u and this will be our v. Okay. You're having u equals to sine x cos hy and v equals to cos x sine hy. From this sine z, you have u and v. Here, our function of z is sine z. F of z equals to sine z, which is equals to omega. We know that omega equals to u plus iv. By comparing u plus iv with the sine z function, that is sine x cos hy plus I into cos x sine hy, you will get u equals to sin x cos hy and v equals to cos x sin hy. Okay. So this equals to dou by dou x of u sin x cos hy plus I into dou by dou x of v cos h sin hy, cos x into sin hy. Okay. So with respect to x, derivative of sin x is cos x and derivative of cos x is minus sin x. Since derivative of sin x is cos x, so you'll get cos x into, you can consider cos hy as constant plus I into, with respect to partial derivative with respect to x. So dou cos x by dou x will be minus sin x into sin hy. Here sin hy is constant. Okay. So this is equals to cos x into cos hy minus I into sin x sin hy. Okay. So we are having d by dz of sin x equals to, that is f. Okay. F dash of z, which is f dash of z equals to cos x cos hy minus I into sin x into sin hy. Okay. So you can write it as, since sin iy equals to I sin hy and cos iy equals to cos hy. Okay. Now we can replace cos hy and sin hy using this. So this is equals to cos x into cos hy equals to cos iy minus I into sin x into sin hy. I sin hy equals to sin iy. So this is of the form cos a cos b minus sin a sin b, which is equals to cos a plus b. Okay. Since cos a plus b equals to cos a cos b minus sin a sin b, so this becomes cos x plus iy. We know that x plus iy is z. Since z equals to x plus iy, so you'll get cos z. So therefore, d by dz of sin z equals to cos z. This completes the problem. Fine. So we have seen a problem from functions of complex variable. Hope you will understand. We'll see you in the next video. Until then, bye bye.